We have seen these sort of spheres before, and whether it is a purely extraterrestrial origin or a mix of an ancient human extraterrestrial development.
Dr. Stephen Greer has just released a shocking new update, claiming that the mysterious Alien Buga Sphere might be older than human civilization itself. Discovered in Colombia and dated to more than 12,000 years ago, the perfectly shaped metallic orb continues to baffle scientists and historians alike. If verified, this incredible artifact could completely rewrite what we know about ancient technology, the flow of time, and the question of who or what might have been here long before us. Physical description and discovery. The story began in March 2025, when people near the town of Buga in Colombia saw a strange metallic ball moving across the sky. It glowed softly and changed direction quickly, almost like it was alive. Soon after, it fell into a quiet field, leaving a small crater and patches of burned grass. Locals said they heard a deep humming sound just before it hit the ground. The object was collected for study and found to weigh between 16 and 22 pounds. Scientists were amazed when they examined it closely. The sphere had no seams, welds, or openings anywhere on its surface. It looked like one solid piece of metal, smooth and flawless. Under bright light, faint symbols and small lines could be seen, carved with extreme precision. When researchers scanned the inside, they found something even stranger. The sphere was made of 3 metal layers, each one separated by a thin air gap, like a set of shells inside one another. In the hollow center were between 9 and 18 tiny metal balls. Each one was perfectly round and smooth, showing no marks of cutting or shaping tools. The design looked far too advanced for its supposed ancient age, leaving scientists stunned. Yet the real mystery wasn't on the surface, it was hidden deep inside. Internal geometry and potential information encoding. Inside the metallic sphere, scientists found a structure that looked more like a machine than a natural object. The tiny microspheres in the center were not placed randomly. Each one sat at a specific distance from the others, forming a precise 3-dimensional pattern. Some researchers believe this layout could act as a kind of data storage system, similar to how computers store information using ones and zeros. The spacing between the microspheres might represent binary states, while the different layers of metal could act like separate pages or sequences in a massive digital archive. To study this idea, teams began using pattern recognition and mathematical modeling. They looked for repeating ratios and perfect geometric alignments that could reveal hidden order. Advanced graph theory helped map how each microsphere connected to others in space, almost like a constellation. Artificial intelligence programs were then trained to detect patterns too complex for humans to see. Some scientists even suggested using quantum neural networks to decode possible messages stored in the sphere's design. Whether the arrangement holds data, energy, or something beyond current understanding, the structure seems deliberate. Every curve, distance, and layer feels planned, as if someone or something encoded knowledge inside metal. But if it holds data, what kind of impact left such a violent mark on arrival? Landing site evidence. The place where the metallic sphere landed near Buga showed signs that something powerful had happened. The grass around the impact zone had turned brown within hours and never grew back, even months later. The soil looked burned but not charred, as if the life had been pulled out of it instead of burned away. Local farmers said the spot felt strangely dry, even after rain. Scientists studying the area believe this could be proof of a high-energy event. One theory suggests the sphere released an intense burst of energy that rapidly pulled moisture from the soil and plants. This process, called rapid moisture extraction, could explain why the ground became sterile without showing fire damage. Tests showed that the clay in the affected soil had changed at a molecular level. Its dielectric properties, how it stores and reacts to electric charge, were altered in a way not found in normal Earth samples. Researchers used spectroscopy to compare the damaged soil to nearby untouched ground, and the differences were striking. The data points toward a sudden, focused energy discharge at the landing site. Whether it was propulsion, radiation, or something unknown, the evidence suggests that the sphere's arrival was far from ordinary. The ground told one story, the sky told another. Flight mechanics analysis of videos of the sphere over Buga show it moving in sharp, fast, zigzag motions. The path was too smooth and precise to be random or caused by wind. This kind of movement means the object had active control, adjusting its position in real time. To move like that, it would need attitude stabilization and directional thrust, technology far beyond what normal drones or weather balloons use. When scientists looked closer at the sphere's surface, they found areas that could hold valuable clues. Small, almost invisible burn marks appeared near certain points, which may show where the air hit hardest during movement. These marks, known as friction ablation patterns, usually appear when an object passes through the atmosphere at very high speed. Surface scans also showed very slight differences in texture, like tiny ripples or dents that might have formed from repeated high-speed turns. Even these small details matter because they can reveal how the object moved and what forces acted on it. Interestingly, parts of the surface showed no signs of heat or wear at all. That absence may be just as important. It could mean the sphere had a way to manage friction or even repel air, something still unexplained by known science. Now, scientists had to prove what they were really looking at. Immediate verification roadmap. To confirm what the Buga Sphere really is, scientists have set up a careful and direct plan for testing. The first step is to study the metal itself. Using scanning electron microscopy with energy dispersive spectroscopy, experts can see every element inside the sphere, even in the tiniest amounts. This shows the exact recipe of the alloy. If strange ratios like extra scandium or copper appear, it could mean the metal is not from any known industrial process. The results can then be compared with aerospace materials and natural ores from Earth to find a match, or show it's something new. Next comes isotope ratio testing. Each element has its own natural fingerprint. Titanium, for example, has 5 stable isotopes, and their proportions reveal where the metal came from. Meteoritic materials have very different ratios than those found on Earth. This test is fast and affordable, often finished within a few weeks and costing only a few $1,000s. After that, scientists will study the metal's microstructure. By examining grain boundaries, they can tell if the sphere was cast, forged, or shaped by an unknown process. The structure of each layer also reveals how much heat it endured and whether it was built under extreme or controlled conditions. The second part focuses on intelligence detection. Passive signal sweeps listen for faint electromagnetic hums below 1 kHz. Near-field mapping checks hundreds of surface points to find hidden patterns or energy clusters. Finally, a 72-hour thermal test watches for repeating heat changes, which could show internal activity. Together, these tests will help reveal whether the Buga Sphere is only metal or something more advanced, made with purpose. But unlocking its secrets would require more than just identifying the metal. Advanced decoding strategy. The next stage in studying the Buga Sphere focuses on decoding its inner design without damaging it. Scientists will begin with interior photogrammetry using advanced X-ray CT scanning. This method creates a full 3-dimensional model of the sphere with sub-millimeter precision. Every microsphere inside can be mapped in exact detail, including its position, distance from others, and the thickness of surrounding layers. This data forms the foundation for deeper mathematical and digital analysis. Once the internal structure is mapped, researchers apply graph theory. In this approach, each tiny microsphere is treated as a node in a network. The distances between them become the links. By measuring these relationships, scientists can look for clustering, symmetry, and hidden hierarchies. Natural objects tend to show random or uneven spacing, but engineered systems often follow strict mathematical rules. Detecting repeating ratios or geometric balance could suggest deliberate design. Next comes artificial intelligence pattern recognition. Using quantum-trained neural networks, computers can compare the sphere's internal geometry to known digital encoding systems, like QR codes or parity-based data grids. These systems look for repeating motifs, self-correcting logic, and mirrored arrangements, hallmarks of information storage. Even a few consistent repetitions could indicate a coded message, blueprint, or data map. Finally, redundancy analysis helps separate design from coincidence. Engineers often include error-correcting codes or checksums to preserve data accuracy. Detecting mathematical constants, such as Fibonacci ratios or prime number sequences, could confirm purposeful construction. Together, these four techniques, imaging, graph theory, AI recognition, and redundancy testing, form a complete decoding strategy. They combine the precision of modern physics, the logic of mathematics, and the power of artificial intelligence. If the Buga sphere truly holds encoded information, this multi-step process offers the best chance to read whatever message or data might be hidden within its silent metallic core. If the sphere truly holds knowledge, what could humanity do with it? Practical applications. If the Buga sphere is proven to be an engineered object, the real-world uses could be revolutionary. The first and most direct benefit would be in energy storage. If its structure or materials show signs of advanced energy containment, that knowledge could power homes far from electrical grids. Rural clinics could operate medical devices without fuel or batteries. Emergency teams could carry compact energy units during disasters. Even aircraft propulsion could become more efficient, cutting fuel use and carbon emissions. The second area would be navigation and flight safety. The sphere's motion hints at precise control and balance beyond modern systems. Learning how it stabilizes itself could lead to smoother flights and safer travel through turbulence. Planes and drones could navigate mountain ranges or cross oceans with better accuracy and less energy loss. Finally, the sphere could change material science forever. Its layered structure and perfect seams suggest a method of shaping metal we do not yet understand. If this process is replicated, it could produce materials that are lighter, stronger, and far more durable. These breakthroughs would reshape industries, from safer cars and planes to medical devices and pressure-resistant containers, proving that one strange object might unlock an entire new era of technology. Of course, none of this matters if the science isn't bulletproof. Scientific Validation Protocol. To confirm any discovery about the Buga sphere, scientists must follow a strict validation protocol. The first rule is the chain of custody. From the moment the sphere is collected, it must be sealed in tamper-proof containers. Each handoff, whether to a lab, analyst, or technician, must be signed, time-stamped, and fully documented. This ensures no contamination or accidental damage changes the sample's true nature. Next comes the two-lab rule. Two independent research facilities must perform the same tests without sharing data until both are finished. Only after results are complete can they compare findings. This process values replication over speed and removes the risk of shared bias or accidental influence. The third step is blind testing. Analysts will not know which samples come from the sphere and which are standard control materials. Every piece is labeled with a random code. This is the same method used in top-tier medical diagnostics to remove personal bias and ensure objective results. Finally, a time-locked release secures transparency. All testing methods, procedures, and datasets are uploaded to public repositories before results are announced. This prevents selective reporting or cherry-picking of data, guaranteeing that the sphere's story, whatever it may be, is told with full scientific integrity and global accountability. But one question loomed larger than all the testing. Could it really be 12,000 years old? The 12,560-year question. The claim that the Buga Sphere is 12,560 years old ties it to one of the most mysterious periods in Earth's history, the Younger Dryas. Around that time, the planet went through a sudden climate shift. Temperatures dropped sharply, glaciers advanced, and many large animals like mammoths and saber-toothed cats disappeared. Some scientists believe a comet impact may have triggered this event, supported by evidence of platinum traces and microscopic diamonds found in ancient sediments. However, the dating of the Buga Sphere must be treated carefully. The test results likely came from surrounding materials, such as tiny marine fossils called foraminifera, not from the metal itself. These small shells can hold traces of carbon used in radiocarbon dating, but metals do not contain carbon-14, so the test may only reveal the age of the sediment or surface contamination, not the true age of the object. This is a common source of confusion in archaeological analysis. If the sphere truly dates back to that ancient era, it would rewrite human history. No known civilization from 12,000 years ago had the technology to forge seamless, multi-layered metals. Such a claim requires careful academic study, verified data, and cautious interpretation, not sensational assumptions. The answers wouldn't come from guesswork, they'd come from radical transparency. Open science approach. The study of the Buga Sphere should follow an open science approach, ensuring transparency and public trust. The first step is public data sharing. All raw research files, such as 3D scans, high-resolution photogrammetry models, and spectroscopy results, should be uploaded to open-access databases like Zenodo or Figshare. Each file must include complete metadata detailing instruments, calibration methods, and testing conditions. This allows experts and citizen scientists worldwide to review and analyze the same data. Crowdsourced research has already proven its value in projects like protein folding and galaxy mapping, where thousands of volunteers helped identify patterns faster than any single lab could. The second part is a public tracker system. This would be a simple, continuously updated online dashboard with 3 key columns: test dates, laboratory names, and results. Every new analysis should appear within 48 hours of completion. Each entry would link directly to full lab reports, images, and datasets. Such real-time tracking lets the global community watch the investigation unfold without delay or secrecy. By following this open model, the Buga Sphere study can set a new benchmark for scientific integrity, where discovery is shared freely, collaboration replaces competition, and truth becomes a collective effort, not a guarded secret. And the testing was only just beginning. Additional testing methods. To uncover more about the Buga Sphere without harming it, researchers plan several additional testing methods. The first is a gentle magnetic stimulus. Scientists will expose the sphere to carefully controlled magnetic fields, using sensitive aerospace testing tools that pose no risk of damage. These fields can reveal how the object reacts to external energy. If the sphere emits a structured or repeating signal, it might indicate internal circuits or responsive materials, similar to field coupling seen in advanced electronics. Next is field forensics, starting with microscratch analysis. Using extreme magnification, experts will search the surface for tiny parallel marks, evidence that could suggest high-speed travel through the atmosphere. Such microscopic scoring patterns are often left by objects exposed to hypersonic flight or re-entry friction. Another layer of study is the residue library. Scientists will collect and catalogue every dust grain, pollen trace, mineral speck, and bacterial DNA found on or inside the sphere. Through forensic palynology, analysing pollen and spores, they can trace the object's possible geographic journey or environmental exposure history. Finally, geophone monitoring will place ground microphones near the sphere for 72 hours, recording any internal vibrations or repeating frequencies. If consistent patterns appear, they could reveal internal activity or mechanical resonance within this mysterious metallic object. 3 paths lay ahead, each one changing everything. Possible outcomes. The investigation into the Buga Sphere could lead to 3 possible outcomes, each with major implications for science and history. The first possibility is that it is an engineered artifact. If researchers confirm consistent data patterns in the microsphere arrangement and find built-in redundancy suggesting error correction, it would indicate deliberate design. Combined with isotope ratios not found in any terrestrial source, this would mean the sphere was purposefully created, perhaps not by humans. Such a discovery could completely transform our understanding of material science, energy storage, and propulsion systems, marking a new era in human knowledge and innovation. The second path suggests it might be an advanced piece of terrestrial technology. It could represent a forgotten or classified human creation, using manufacturing techniques far ahead of their time. If this turns out to be true, the find would still have enormous value, uncovering lost breakthroughs in metallurgy, energy systems, or flight technology. It could also carry serious national security implications if it originated from covert research. The third and simplest possibility is that it is a natural object with rare features. Even then, the study would not be in vain. The testing methods, imaging protocols, and analytical standards developed during this process would set a new benchmark for future scientific investigations of mysterious artifacts. While scientists worked carefully, the internet had other ideas. Sample preservation and media reactions. Researchers are following a strict sample strategy to protect the Buga Sphere's integrity while allowing scientific testing. Only the smallest possible shavings, measured in micrograms, will be taken for chemical analysis. Non-destructive techniques are always the first choice. These include X-ray tomography, MRI, optical microscopy, infrared imaging, and ultrasound scanning. Each method offers a different way to explore the sphere's structure without damaging it. The goal is to keep the object as close to its original state as possible so that future technologies, which may be more advanced, can study it further. Every step in the process is being logged and filmed to maintain transparency and accountability. Meanwhile, media coverage of the discovery has exploded. Viral videos have gained millions of views worldwide. Some clips show people chanting near the sphere, claiming it vibrates or changes weight in response to sound. Others feature claims of fiber optic-like internal wiring made by Mexican researcher Jaime Maussan and his team. However, none of these statements have been independently verified through scientific methods. Many of the sensational stories spreading online appear to come from speculation, not data. The true story of the sphere can only emerge through careful testing, peer review, and open scientific collaboration. The Buga Sphere stands at the edge of science and mystery, a silent object that could redefine what we think we know about our past and our technology. Stay curious, stay informed, and follow for more verified updates as this investigation unfolds, because history may be rewriting itself right now.